Hi, my name is Ramna. My personal blog is .netiq.com. You can follow my blog at facebook.com/.netiq. In this screencast, I am covering the facade design pattern. Basically, it's a very important design pattern, I can say, and most of our projects we are knowingly or unknowingly we are using this design pattern. Maybe after this screencast, you might know that you already implemented this design pattern in your application or even in architecture. Yeah, basically it's a structural design pattern. As you know that design patterns are three types like creational or structural or behavioral. The facade design pattern falls under the structural design pattern. What is facade design pattern? Basically, facade design pattern is a it's a high level interface. It means when you are developing a API or means the business component or any data access component, rather to expose all your subsystems, subclasses, and their methods to the user who is consuming your DLL, rather exposing everything to them. Instead of that, you expose a high level interface, means high level class, one class to the functional device, a main one class you need to expose, and that class has the key functionality methods. Internally, those methods is going to interact with the subsystems. It maybe it's interact with the different DLLs, classes, and those methods and properties. Rather, you expose everything to the user and decide him to know what are the methods he has to use. Better to provide a one high level interface, one high level class, which is going to provide the main key functionalities. Each key functionality is going to interact with different subsystems and different classes and different methods. That way you are simplifying the user task. Like user just he comes and directly access that facade class, and he will call the functions whatever he need. So it's easy to understand for the users and easy to use it and easy to test it. I will show you one example on the facade. That way you may betterly understand that what is the facade design pattern. If you see, I'm taking the shopping cart as an example. My DLL is a shopping cart DLL. So whoever wants to implement the shopping cart, they can refer my DLL and call the shopping cart related functionality. So the shopping cart means it has so many functionalities like finding the stocks and the taxes, item cost, is item is available or not. These are the common functionalities comes with the shopping cart. So instead of expose all the classes stock, taxes, item cost, and shipping, so many other. They just I'm covering the only three classes here, and expose all these classes to the user who wants to use the shopping cart DLL, and let them decide to what the method they have to call and what sequence. Instead of giving a confusion to the user, I will provide the shopping item. Shopping item is the one class. You have so many facade classes. The shopping item is one facade class. Internally, it has a method called add item to cart. This add item to cart is going to call the method of stock class. It's going to call the methods of taxes class. It's going to call the methods of item cost. So what I did is the stock, taxes, item cost, I made those classes as the internal class. So even the client who is consuming this DLL, referring this DLL, they cannot see these classes and what's there inside these classes because it's internal. The access modifier I specified as the internal. The shopping item is the class I specified as a public, so that the client who is referring this DLL, they can see the shopping item at the facade class, and whatever the methods existed in the shopping item class, they can able to access those methods. I'm straight away going to my source code, the implementation of this. See here, the shopping is the DLL. Here I have the shopping item. This is the only public class I have, and the rest of them has a stock. It is an internal class. It has the first check items stock by item ID. If I pass the item ID, I will get to know that the items is stock existed or not. And once the user decided to add to the cart, then I need to lock the temporarily the certain quantity. If I want to buy 2 books, then I need to lock those 2 books. So no, in the stock, then it will detect the quantity 2 temporarily. and the taxes. If I pass the state ID, I will get the tax. And the item cost, it is going to give the, if I pass the item ID, it's going to give the item cost. These are the independent classes and those associated methods. The shopping item, if you see this, this is the public class. It has a method called add item to the cost, add item to the cart. Just user will pass that item code and the quantity. But internally, what I do is I just create a stock class instance and checking that if the stock existed or not for that item. After that, I need to write one more condition. If they existed, then I need to lock temporarily. Then I need to find the item cost. Then I need to find the tax for that state. And then after that, I apply the tax and do that. Means I didn't implement everything, just roughly to get understand what is the facade card. Just I high levelly I created few classes and few methods. Okay. Uh, Suppose if the in this actual this is the client application which is using this shopping DLL, and in reference you see the shopping DLL, and you go to the programs class. Here shopping item, new shopping item, I just add item. This is what I'm passing. So otherwise the client has to know all these classes and all these methods, and he has to know the in what order he has to call to in what order the classes he has to instance create and call the methods to make one item add to the cart. So rather you will provide a facade class which is going to give the high level methods, and those methods they are going to use. In physical world, non-computer world, if you want to tell an example, if you take a car, if you want to on the car, means you need to put the key and start it. That's it. You know that how to start the car, just put the key and start it. But when you start the car, it is going to do so many operations internally, like so many checks. If the airbags is correctly, means if the airbags is correctly set or not, and if the gas indicator it will show, and also it says the seat belt is buckled or not, and it also engine service is required or not, and so many checks internally it does. Just you are initiating a function like owning the key, but internally it is triggering so many functions, and it is doing by doing by itself. That means that as a user you just start the key, and it's going, the rest of the things is going to take care by that starting of the key. In the same way, facade class is the starting point. You have a one high level method. If you call that method, the method is going to call all the subsystems and subclasses associated methods. I hope you understand the facade design pattern, and in my next screencast I will come up with another design pattern. Thank you.